you, Itiel. It was really nice, and I love making cakes, even not as a DevOps, so very enrichment. My name is Itiel Shwartz. I'm the CTO and co-founder of Commodore. We are the first Kubernetes native troubleshooting platform. In my past, I worked as a developer and as an ops person. I don't really love the term like DevOps. For a couple of years in big companies such as eBay, and also at very small companies such as Rookout, where I was the first developer. I really like Kubernetes. I like Docker. To be honest, I also like tests and CICD, which is like a small fetish of mine. This talk is going to be about how we are going to go to Kubernetes, how to build the perfect or like a good CI/CD solution, and staying alive. So I think that like everyone talked about this in this conference, but Kubernetes containers, they are eating the world. Everyone is now trying to be cloud native. 95% of new applications are already Dockerized. And we see this as a huge trend, and more companies are moving from their old legacy system, their old legacy monolith, into microservice and Kubernetes. So this talk is going to be specifically tailored to Docker and to Kubernetes, but you can also take the gist of it to serverless or other cloud-native solutions. So is this talk going to be why Kubernetes is so awesome and I should stop everything I'm currently doing and basically move to Kubernetes? So the answer is like no. Like Kubernetes is great, but this is not what I'm going to focus on today. What I am going to focus on is how we are going to move to Kubernetes, how to migrate your existing CI/CD tools and solution to this new area, to the cloud-native area. So I know that Kubernetes, again, like looks really great, but it has its downside. And the main issue with Kubernetes is the fact that it looks so easy to get started. Basically, like a Kubernetes hello world is you take a very short YAML, you do kubectl apply, and you get your application running in production. So it looks very easy to get started, but the main issue with that is that people just move their existing legacy code into production, into like Kubernetes, without really thinking about migrating the CI/CD solution, the monitoring solution. And like it said that like with Kubernetes, it's much easier shooting yourself in the leg because it looks so naive and easy. So what we're going to talk to you today is we're going to first start with the monolith, basically do a little bit of like a history review of the past days without Kubernetes. Then I'm going to talk a little bit about the new challenges, the new issues coming with the move to Kubernetes and microservices. Then I'm going to talk a little bit about the ideal, what are we aiming for and why are we aiming together. Then I'll give a couple of real tips and tricks from my personal life and the companies I used to work and Commodore on how to do it successfully. Then we're going to talk a little bit about cheating, how I can do something even without spending a lot of time on building the perfect CI/CD solution. And then I'm going to conclude. So first of all, I'm going to talk a little bit about the past because we need to know our past in order to move forward. I think that the monolith had a lot of issues with it. Basically, it was for those of you who don't really know monolith because you started when everything was Dockerized and with microservices. In the old days, you had your very big application. Deployment took between a couple of hours to a couple of days. You had one single pipeline that tested the monolith, and usually you also had a step for a QA or something like that to check before moving into production. But even the monolith had a lot of issues because it was hard to deploy. It was hard for certain teams to move fast while the other teams are lagging behind. It had one very big advantage, and that is it had only one single pipeline. It was very clear what changed, like what changed, the monolith just changed. And it had years of experience of DevOps, IT people, developers, who was used to working with the Jenkins or the other like legacy systems in order to test it and in order to deploy to production. So now I'm going to talk a little bit about breaking the monolith, how the world is currently looks like in today modern applications. I will say that this is true for both Kubernetes and microservices. Basically, for a lot of companies, you have one pipeline for each new microservice. It has a lot of advantages because different teams can write their own pipeline, and also they can move more rapidly because they can deploy their code to production faster. The downside of it is that one change in a pipeline doesn't really affect the other. I know that it doesn't really sound like a downside. It sounds like a feature, not as a bug. But when you're working from more of an ops point of view, where you want to have the same standard across different repositories, across different microservices, it's very cumbersome going from one repo to the other and doing copy-paste each time when you want to add a new feature to your code. So even the move to microservices solve a couple of issues that we had with the previous CI/CD pipeline. On the other hand, it created a lot of new issues. Another big issue that was created by moving to microservice is that developers are now responsible for parts of their CI/CD. Again, it's not really a bug. It's more of like a feature. A developer should have end-to-end responsibility. The main issue is that they lack the knowledge and skills in order to operate a good CI/CD pipeline. And when you throw everything to the developers without giving them proper tools, proper training, you get a very poor and malformed pipeline. So what is a good CI/CD? I'm going to take a second here and talk about the philosophy or the culture aspect of things. So again, in the past days, a CI/CD was usually a couple of scripts, maybe Bash script, maybe Chef or Puppet or something like that, that were tailored together in order to move our application from the local environment into production. Today, I want to see CI/CD treated the same way a production code is treated, and that means that it should be easily tested. You should be able to run the same code both on your local development and where the pipeline runs and get the same result. And you should make sure you understand what is happening on the pipeline. And those things sounds quite obvious for people who come from a developer world or like more of a dev-oriented point of view. But from people that come from IT, a lot of the times it looks quite weird, like why do I need to test my test code, my CI/CD code? It doesn't really make sense. So what I'm going to talk with you now is it makes total sense if I was talking about a normal application. But for some reason, when I'm talking about CI/CD, it looks weird for a couple of people. So the first thing is, why do I need to have a good CI/CD? Like I talked about the problems, I talked about the monolith, the microservices, but why should I invest manpower and time in building this right solution? So the main reason, and I think every lecturer already talked about this, that our goal is to bring value to our customers. And that means that we should strive to have our code, our features, our bug fixes from the local environment into production as fast as possible. Because a code that is currently stuck in QA or a code that is in a feature branch but the test fails, it doesn't help anyone in the organization. And we, as the ones who are building the CI/CD pipeline, should have in mind that our goal, our success will be when the code will move as fast as possible from local into production. I will add another thing to the mix for what we should aim to have, and this is confident. And I'm going to talk about that quite a lot during the next few slides. But we should strive to make sure that people that are running code in our organization, and it can be the DevOps or the dev, should have full trust in the CI/CD. When they deploy to production, they shouldn't be like, I really hope I'm not breaking everything right now, but for the contrast, they should be, okay, yeah, I just deployed 10 times a day into production. Everything works as expected. I'm not really afraid that I'm going to hurt my customers. Okay, so a little bit about what does it really mean. The first thing is don't repeat yourself dry, for those of you who don't know it. This means the ability to share the same component between different microservices, between different pipelines. And again, for anyone who wrote code, it makes total sense. If I'm doing the same set of operation over and over, I would simply write a function and call it. In CI/CD, it's less obvious. What I see that people tend to have is the same YAML lines written time after time after time with copy paste, copy paste, copy paste. And that means when I want to upgrade my pipeline, when I want to add a new feature, I need to go to all of these different places and edit them. I can give a very simple example of adding security checks for my pipeline, and then think about the fact that you need to go to a different, like 100 repos and add the same line of adding this security check over your containers. And again, I don't think it's like a new concept, don't repeat yourself. I think it is quite new in the CI/CD world. The ability to run locally and get the same result as you get on the CI/CD pipeline, again, like Docker, this was the exact goal of Docker, the ability to run the same code and get the same result between different operating systems. Think about the fact that your tests are going to fail. Like, I'm saying it as a fact. It doesn't really matter where are you working at. Things are going to break. And you need to ask yourself, how much time am I willing to spend every time a test breaks on the CI/CD? And what I see in a lot of companies is the fact that every time the test fails for some reason in the CI/CD, the developer is like, yeah, but it works on my machine. So, okay, it's nice that it works on your machine, but the code is currently not in production. And we should make sure that the feedback loop, once you have a failed test, to the minute that you understand why it failed and fix it, should be as minimal as possible. The third thing, and very important thing, is it should be very easy to get started, but also very easy to extend. And I know it sounds a little weird. Why do I need both of them? So first of all, think about adding a new microservice to your company or a new developer that just came in. It should be very simple for them to be able to understand what is happening as part of the pipeline. On the other hand, if I'm a power user in my company, if my microservice is a little bit different than the other microservices, I should have the ability to extend some part of it. So this usually, like the third one, usually we can get there by having a very strong default that are good for most people. But on the other hand, it is possible to extend them for power users. And the last thing is, again, very much like production code, like a real application. Your CI/CD is going to change. The pipeline is going to change. We are going to add more and more tests into the mix. We are going to add more stages. So it's not like I'm going to write it once and then that's it. It is an iterative process. OK, so I talked a little bit about the culture and like the behind the scenes. Now I'm going to give you a couple of like real world advices on how to implement some of those things. So I will say all of those advices are like battle tested, but you might came up with your own solution, and that's also great. So the first thing that comes to mind is multi-stage build. Like I said, everything here is going to be specific to Docker and for Kubernetes. And Docker has the ability to do Docker multi-stage build. And that basically means that you can have the same Docker file, and in the same Docker file have different steps, different pipeline steps, if you will. So you can say the first step is going to build. I'm going to build my application, and I'm going to call it like layer 1. Then I'm going to test my application as part of the Docker build mechanism. And that means that I'm going to take the artifact that I just built on the first step and use them in order to test my code. And again, I know it sounds a little bit weird. Why should I have my test as part of my Docker build mechanism? But because Docker is so great in making sure the same thing runs both on the local environment and in production and on the CI/CD, it makes total sense to use the same capabilities in order to do our test in a very easy way. Also, this allows you to get the Docker layer caching capability for your advantage. And that means that if nothing changed, then the test layer is also already cached, and the CI/CD will just be faster. So that basically means use the Docker build as a mini pipeline, usually for unit test, in order to rapid the speed process and the build process. OK, but I'm sure now you're asking yourself, OK, like it's very nice for unit tests, but my application is super complex. I can't have everything as part of the Docker build. I need database. I need other microservices. I need a lot of different things in order to test my application properly. And like I totally understand you. And this is why I recommend using Kind. Kind, for all of you who don't know it, it means Kubernetes in Docker. It is the ability to run a full Kubernetes cluster on top of a single Docker image. And this allows you to take your same architecture that you have in production, or a very similar one, and to have it as part of your CI/CD code. Think about every time you are doing a branch check that you are deploying a full application into your cluster, and in this case, the cluster is simply one Docker image, and test on top of that cluster. So I know that a lot of people, and we also started by doing the same integration test using Docker Compose, which gives you a very nice solution for getting started. But as your application grows more and more complex, and as you move more and more into Kubernetes-specific and tailored features, having Kubernetes in order to test your Kubernetes makes total sense, because it's very easy to take the same Helm chart or very similar Helm chart that you're currently using in production and simply use it as part of this test, the test step. I will say it won't really work if you have like thousands of different microservices. It works quite well for anything between a couple to around 100 microservices. OK, so we talked about the unit test. We talked about the integration test. But now let's talk about don't repeat yourself issue and basically where should I run my pipeline. So like I said, Commodore is a relatively new company. We are helping developers to troubleshoot Kubernetes. And when we started, we tried to find like the perfect CI/CD solution for our needs. And we started by trying a little bit of Jenkins that all of us already know. We played a little bit with Circle CI. And I will say that all of those like solutions are quite good. I know that JFrog also has one. We ended up using Buildkite, mainly because Buildkite is a CI/CD solution that allows you to host your own agent, basically. They don't have a SaaS offering. But more than that, with Buildkite, you can have your pipeline as a Python code instead of basic YAMLs. And by moving from YAML into code, you can do things like for loop or calling a function, things that make total sense like in a developer standpoint. But again, for like a CI/CD solution, they are usually YAML, and you can't really do those sort of things. Jenkins has its own groovy pipeline that allows you to do similar things, but they are hard to use. So in Commodore, we use Buildkite. We run all of the worker on top of our Kubernetes cluster. Again, we are leveraging our knowledge and experience of Kubernetes in order to make the build process more fast and efficient. By also using the Python pipeline to make sure we are not writing a lot of code every time we add a new capability or add in a new microservice. The last thing, or the last practical advice I'm going to give you is use feature flags. So feature flags is a little bit like cheating. So for all of you who don't know feature flag, it's the ability to open a part of your application for a specific number of user, organization, segments, and so on. And this allows you to go take your code from the local environment into production, open it up only for the test mechanism or only for your organization, and be able to test it very rapidly. So what we see in Commodore is that we take feature that we are not really sure that works perfectly. We move them to production, but we open them up only for Commodore because we are eating our own dog food. And this way, you can go from local code into production in a couple of hours. And you don't really need to be afraid that you're going to hurt the company SLA or like KPI because this thing is open only for a specific set of users. So feature flags is like a cheating option because maybe you do a fast track only to check that your code is running well on production. It's not like the normal CI/CD solution because a lot of the times feature flags don't really include tests. It depends. But it does allow you to move fast. And like I said, the game here is to move fast from the local environment into production. And if I can go and move to production, test things, find out that I have issues without going like the full circle, just so the developer can develop faster, it's great. I will say, even if you are using feature flags, make sure you know when the feature flag is open and closed. So by accident, you don't open something for the rest of your users without you being ready. OK, so the last thing is the ability to deploy together and revert together. It's not really like a CI/CD thing, or more of like a real production issues that we encounter for a lot of our customers. Like microservices should be completely independent. And in general, I advise you to make sure that your application don't really have dependency between both of them, or like all of them. But in the real world, what we see is that one application affects the other microservices, or the other application. And once something like that happens, when team A is deploying a new code into production, but team B doesn't really know that team A just deployed and team B has its code breaking in production, it is very hard, A, to detect, and B, to go back in time, because no one really knows what is currently running, what was the good state of the system, and what is the thing that broke the system. So what I'm saying here is make sure that you know what versions are running in production. If you have a couple of applications that you already know that they are binded, even if it's bad and you have a sprint or like a roadmap on making sure that they are not going to be dependent on one another, be sure that you know that they are deployed together, or at least have the ability to monitor the deployment into production so it will be easier for you to roll back. OK, so some final tips. We're using TestCafe, and you can also use Cypress or Testim.io in order to test our code end-to-end. And for those of you who don't know TestCafe or like other end-to-end automation tools, it's the ability to test your code not only from like the API and backend test, but to simulate the customer end-to-end. And by adding TestCafe and TestCafe test to our pipeline, we are able to deploy to production without the fear of breaking something, because a full end-to-end test touch everything, basically. It touches the UI, the database, the backend. Everything is covered by running a full end-to-end test, a full integration test. I know, again, that for a lot of companies, end-to-end tests, or like TestCafe or Cypress or Selenium tests, are something that is more tied to the front-end people, not something like the backend or the developer, like the database engineers need to think about. But by adding the right number of tests, the right number of end-to-end tests, you can gain full coverage of your system every time you deploy to production. And this, we found this very useful in order to make sure that things are not breaking, not only on one part, but across the system. I will say another very important tip is changing and adding your test after you have a major incident or after you are having issues in your production. And again, I can't really stress this part enough, because like I said, you need to have confidence in your CI/CD pipeline. You need to make sure that if your code passed all the tests, passed the integration test, then you don't really need to be afraid. And in order to achieve that, you need to start with a certain set of tests. But every time your test missed something, and it is going to miss something, you need to think, can I add more tests in order to improve it? Do I need to add another part to the test pipeline, making sure this won't happen again? And what we do in Commodore, and what I find as a best practice, is to finish every postmortem that you do after major incidents with the question, why didn't my test picked up on it? And sometimes you don't really have an answer, like the thing is so weird that it's very hard to test, and I don't think you need to add tests necessarily after each postmortem. But I think having this state of mind of making sure that the testing match our real incidents, our real issues, is very important in giving the developers, in giving the organization the trust they need in the CI/CD pipeline. So I'm going to do a quick conclusion of the talk today. CI/CD pipeline is it's not like a set of random script binded together by glue code like it used to be. And I know this was the way that it was for years and years, having a set of bash scripts that run certain machines, certain tests. No one really knows it other than the very expert DevOps or like IT person, and no one can really change it because no one understands Bash good as well as he does. And I will say that spending the efforts on the CI/CD pipeline is a thing that returns the investment very, very fast. It will return the investment both because your code will move from locally into production faster because everything will be faster, but more than that, it will save your developers and your DevOps a lot of precious time of troubleshooting and debugging tests that failed in the CI/CD. And it will give your developers the confidence to change things and to change the code inside their pipeline, inside their test suites, without the need of an external help. So basically, you will have the ability to gain faster movement, not by skipping on important things such as test or integration test, but on the contrary, you will move faster and have more confidence, mainly because you trust your pipeline and you are not the only one that writes the pipeline, but it's something that all of the team, all of the organization is investing time in. So that was pretty much it. I will say that feel free to ask me more questions about CI/CD or about Kubernetes troubleshooting later on. And yeah, thank you very much.